Learn at Cloud Analytics. So, yesterday we have started off with data modeling basics, and today we are also going to continue on the same. So, we have just started off with a few terminologies in data modeling and Power BI. So, and today I'm going to I'll try to explain some additional topics that would help you to understand the data modeling in a better way. So, let me quickly go into the topics for today. So before I dive in, let's quickly recap on what we have addressed yesterday, and then I will go back with some additional topics for today. So, yesterday we spoke about what is data modeling. So, data modeling is all about how we are trying to relate multiple tables together in Power BI. Now, why this is important? Because at often times in real time, when we are working in a project, we are not likely to have only single table to connect and pull the reports out of it, but rather we are required to connect to multiple data sources, and therefore there is a need to identify the importance of relating these two tables or multiple tables in in an efficient manner so that the right data is populated on your reports as you work on it. And therefore we have looked into what happens if we do not define a relationship between two tables, and what happens if we relate the tables with a relationship. So for example, let me quickly go into a layout and I will try to show you the difference between that. So I'll try to bring in my orders table, and then I'll try to bring in my order details table. So as you could see, by default, Power BI has identified the relationship that is existing between both the tables. So relationship is nothing but how this orders table can be connected or is associated with this order details table. So there is a relationship, and the relationship is nothing but based on a specific column, and these columns are referred to as a primary key and a foreign key based on what type of a table is that related to. So in general, in a data warehouse, we have mainly tables being stored in a master table and a transaction table. So the master table generally has all the records that are related to the business information. So for example, if I consider a banking information or a banking example, right? Now let's say that if I approach a new bank and apply for a new account in the bank, now first uh, the first thing that the banker might ask me is to produce the KYC documents, and then based on my KYC documents that have been submitted at the bank, they will try to create an account, a unique account in my name. And how do I define it as a unique account? Because there is a unique key being generated against to my account details. So for the first time when they try to open an account in my name, right? So what are the few elements that gets generated, or what is the information that gets stored in their database? uh, Firstly, it would be a account number that gets generated, and according to along with my account number, there would be another additional columns which specify who is the customer and the customer name, and then would also be some KYC information like what is my date of birth, what is my address, what is my contact number, and my email address. So these are all related as the master table records, because this sort of an information is not quite oftenly been changed or modified, so it's not easily accessible to the user. But rather, if I have to make any sort of a modifications to either of them, I would have to approach to the nearest banker and would have to produce the necessary documentation to affirm the needed changes to be applied in my account. So therefore these records, since it is not uh, commonly changed or not oftenly changed rather, are termed or are classified and stored into the master records, and that is why it is called as a master table. On the other side, once my account has been created in the bank, then what happens next is that I would rather perform a lot of transactions on my account, right? So what kind of a transactions can be performed? So it could be like I might do some deposit in my account or withdraw some amount at the ATM or maybe at the bank itself, or probably I might try to query the data just to see like what is my current balance in the account and what are the latest transactions that I might have performed in the current month or the prior last few months, right? So these are the generic transactional information that gets stored on a timely basis and gets updated quite often, and therefore this particular records and therefore this sort of a records are commonly being stored in the transactional table. So in this way, all of the data warehouses, so this is just as a banking example, I have given you the scenario just to make sure that you understand the terminologies and how the data has been classified and stored in the respective tables. Now in the data warehouse, like I said, we normally have both the tables like the master and the transaction, and within the master and the transaction tables we do have the dimension tables and the fact tables, through which all the tables are interrelated and stored as well. So here on this particular example, there are two different tables, primarily orders and the order details. Now the orders table is nothing but the lookup table or the dimension table. On the other side, the order details table is nothing but your transaction table or the fact table. Now, by looking at the table itself, how do I identify or make sure that this is a fact table or this is my lookup table or fact table or the data table? By looking at the numeric information. So, most commonly, whenever you have the relevant information being stored on a specific table with unique records, then that particular table is referred to as a lookup table or a dimension table. And this particular table usually doesn't hold any sort of a metric information or a facts related information. So let's say like the sales or the profit or the quantity, or so all of these are classified or termed to be as a measures or facts. Okay, so let's try to understand again a little deeper into it. Now, what is a fact and what is a dimension? So dimension is nothing but based on that particular values that are stored in that column, if we are able to assess the business, then that is classified to as a dimension. On the other side, if I have to understand how the business is performing, then I need some numbers, right? And that is nothing but your facts or your measures or metrics. So all of them are synonyms to each other. So even if someone calls this particular term as fact or measure or metrics, do not worry, all of them are still the same. All right, now let me give you a very good example here. So let's say that there is let's say there is uh, a Walmart retail store, right? Now, the head of this particular retail store company would like to analyze how the business of Walmart is doing in a specific region or for a particular duration. Now, if I consider this particular line or this particular description, right, based on the business requirement, how do I assess which one is termed as a dimension and which one is termed as a fact? So, here the uh, company head would like to analyze their overall business or growth for a specific duration, like let's say like the for the last 1 year. So in this description, how do they analyze the business growth? So, business growth or the performance of any business can only be evaluated based on numbers, right? Based on the revenue that is incurred for the business, based on which they are able to make an um, confirmation or make a prediction saying that yes, for this particular duration, the company has incurred some XYZ revenue and therefore it is doing profit and we are in good shape and good position. Or let's say that if the numbers are not showing up correctly, or like let's say if the numbers are not showing so good, like in negatives, or there are some dips in some few months and there are some ups in few months, then in a all overall, on an average mode, if I can consider, there might be some losses incurred at the overall period, and that is where maybe the management might need to look into why the losses have been incurred for a few months, and also that had impacted the overall growth of the company, so that they are able to make some viable decisions in order to improve their businesses, in order to reduce those gaps going forward. So in this way, we are able to assess and understand and relate these dimensions and facts in our day-to-day business as well. So I hope these basic terminologies are now clarified. Now let's go into the actual topic for today. All right. So I have created some documentation which I felt that it would be important for each one of you, so that whenever you're trying to attempt any interviews that might have scheduled, right, it would be like a quick reference as well. Sometimes we often forget these basic terminologies, and it may not be asked, but it's good to have this terminology understandings before you enter into any company, or probably even if you try to attempt any interviews as well. All right. So, what are data tables and lookup tables? So, I have already explained this, but let me give it a nutshell. So, data tables are nothing but these are your fact tables that usually contains the metrics information for that particular business to know the growth, or analyze how the core business is doing. On the other side, lookup tables or the dimension tables are nothing but these usually contain all the descriptive attributes of that particular data in the fact tables, and these are mainly used to uh, perform any filtering or slicing of the data on your respective visuals. And on the other side, lookup tables often have lesser data because it usually have unique values, and also it just stores all the business relevant information and does not hold any metric related stuff, right? And therefore the volume of the data is comparatively lesser. And while the data tables, because it actually stores the transaction table data, it's heavier, and therefore there is a large number of records being noticed in this particular tables. Okay. So now I hope that the distinction between data and the lookup tables is now clarified. Now going forward, let's understand what is a relationship and modeling. So relationships, again, like I said, these relationships are mainly created based on the primary key on your dimension table or your data lookup table to that of your foreign key in your data table, which is nothing but your fact table. So the primary key has certain attributes or certain features through which it has been classified as a primary key in a table. So to be identified as a primary key in any table, there are certain features that it has to address to. The primary one is that that particular table or that particular column should have unique records or unique values, and also it does not have or it shouldn't have any null values and duplicates. And these are the primary attributes of any column to be classified or defined as a primary key. On the other side, in a fact table, the same primary key, when used in a fact table, it is called as a foreign key. Now, why is it called as a foreign key? Because in for a foreign key, it does not have similar attribute conditions like to have it do not have a duplicates or null values. But here, and when it has been used in a data table, it can have a duplicate values and also contain null values, and so therefore it is referred to as a foreign key in a lookup table. And it's obvious because the same customer might perform multiple transactions, so the records are duplicated. So now if I have to relate both the tables together, like let's say the customer table versus the transactions of the customer tables together, I would have to identify based on what particular common key can I be able to relate these two tables, and that is nothing but the primary key and the foreign key relationship. So let me quickly go back to the model view. So here in this particular data model, as you could see, I have related both these tables based on the order ID. So how did I know that I can relate order ID with order ID? Because in my orders table, it's basically a lookup table that has only the orders related information like the order ID. So that is my primary key in orders. And the same order ID key, when it has been referred in my order details data table, it is termed to be as a foreign key, because here it has duplicate records, and that is why you could see that there are multiple records denoted by the asterisk. So this particular relationship or this particular line that is connecting from one table to another table is nothing but the relationship. All right. So we will go step by step. So do not worry. I will explain each and everything. But because we have introduced the terminology of relationship, let's understand what are the different ways of creating relationships in Power BI. So in Power BI, there are two different ways in which we can be able to create relationships. One is the automatic way, which is like the auto detect, and the second one is the manual way. Auto detect feature is something which can be enabled automatically in our Power BI properties, Power BI desktop properties. If not, Power BI, uh, once it is enabled, then Power BI can identify if there is any commonality that exists between two tables, and it will try to relate those two columns and those two tables together. And also automatically it would provide you with the cardinality that exists between those two tables. The other one is the manual. So manual is nothing but, like, let's say if I remove this particular relationship, right now if I would like to create a relationship between these two tables in a manual approach, I just need to drag this order ID or the primary key on my orders table and place it on the foreign key in my uh, data table, and then immediately I could see this particular relationship window where I can identify, or I can just reassure or reconfirm which is my two tables that I'm trying to relate with each other and based on which particular common column. And below to that, I see there are few options. The first one being the cardinality. So cardinality in Power BI, you do not need to worry about it to understand much more about it, but just we need to know what are the different types of cardinalities and what is it all about. So you don't need to worry about choosing or selecting the right one, because Power BI, through its intelligence, by default it would recognize and identify the right cardinality, so you don't need to change anything or modify anything unless there is a need to do that. And on the other side, there is a cross filter direction which has two values within that. One is the single, the other one is both. So we will try to go through that in the next few seconds. And then other important property here that you could see is make this relationship active. So if by default this is selected or which is made as an active relationship, and that is nothing but the relationship arrow that you see here, right? It is indicated by a thick line arrow. So if I say that okay, I would like to make this as a inactive, then that would be denoted with a dotted line, and dotted line indicates that it is inactive relationship, and therefore any filtering of the data using that inactive relationship does not work. Okay, so okay, so now let's take a deep breath. I know that we have spoken a lot about relationships, cardinalities and all, but let's go a little bit deeper. Now there are two ways of making a relationship active and inactive, right? Now, how many such inactive relationships or inactive relationships can be established among tables? So, at any given point in time, between two tables, only one active relationship can be defined or created, and we can create n number of inactive relationships between those two tables. So no matter how many you might wanted to create on different columns between those two tables, you can still be able to go ahead and create inactive relationships. All right, so this is what you might need to remember. Now let me go back to the topics. I think we've already looked into the schemas and the dimensional modeling yesterday. So star schema is where you would see that so you have a fact table situated in the center, and then you have the dimension tables arranged and around it, which is nothing but all the dimension tables are directly connecting to your fact table. And in the snowflake schema, all the dimension tables are not directly connected to the fact table, which means that there is one outer layer dimension table which is connected to another dimension table through which it is indirectly connected to a fact table. So such kind of an arrangement of tables is nothing but a snowflake schema. All right. Now, okay. So this is all about the cardinality. So I've given a lot of explanation and some description so that it would be helpful. But on very high level, let me just try to explain it to you. Cardinality is quite important because only through the cardinality, Power BI can be able to understand what is the relationship or what type of a relationship does both the tables have, and based on which the results have been populated in your report. So there are basically four different types of cardinalities: one to one to many to one, and many to many. So one to one cardinality is similar to that of your inner join in SQL. So what happens in a inner join? So if one value in the first table has only one value in the second table, then such kind of a relationship is defined as a one to one cardinality or a inner join. And similarly, one to many is nothing but if there is only one value in the first table and multiple records in the second table, or if it is related to multiple values in the second table, then it is referred to as a one to many, which is identical to that of your right outer join in SQL. And similarly, many to one is identical to a left outer join, which means that there are multiple records that are connected or associated with a single record in the right table, and therefore it is referred to as a many to one or a left outer join, or it's similar to a left outer join in SQL. Whilst the last one is many to many, it says that uh, there are multiple records in the first table that are associated to multiple records in the second table, and therefore it is termed as a many to many. So usually in real time we do not encourage, or it's not encouraged to have many to many cardinalities established in your data model, because it leads to a lot of performance issues, and also a lot of ambiguities that are provided on your data set as well. So there are a lot of problems to that. So we will look through them one by one as we go ahead in the next steps. Okay. So I hope these topics are now been clarified. So let me go back to the topics. So we've understood what is the data model, the difference between a data table and a lookup table, and the basics of data modeling and defining the relationships. Now let's try to go and understand what is the difference between a relationship versus merged tables. So let me go back to my Power BI desktop, and I have already created couple of models, and I have done a merge query as well. But let me quickly show you what it is all about. So here I have connected to several data sets, as you could see on the left side within the queries pane. So I'm currently on my Power Query editor, which is important for my data transformation layer. So here what I'm trying to do is I would like to compare the difference between a merge query to that of a relationship in Power BI. Right now, let's try to create a merge query. So here, um, okay, let me try to look at. Okay, so I'll try to pick the orders table and the order details table, and I'll try to create a merge query. So merge query in Power BI is nothing but similar to that of your joins in SQL, whilst the append queries are similar to that of your union in SQL. So you just need to understand these basic differences so that you know when to perform which query, and if it is really required. Now let me go back to this merge queries on my home pane. So here I have an option to select the drop down next to the merge queries. Select the merge queries drop down, and now I'll select merge queries as new. So the moment I select merge queries as new, it brings up this new window where I'm allowed to select the tables on which I'm trying to perform the merge query. So the first table I would like to have is the orders table, while the other table is my order details table. Now, based on which column are we trying to merge, or how are we trying to combine these two tables? So, based on my order ID on my orders table and order ID on my order details table. And as you could see, the moment I've selected the common column or the common key that exists in both the tables, the join kind shows us that for this particular merge query, the right join kind would be the left outer, which says that all from the first matching from the second, and which is ideally the right join, which I would usually or I would normally be attempting to select for. So, as I said, Power BI by default has this intelligence to identify and provide you with the right join kind when you perform a merge query. And similarly, when you try to select or when you try to perform a relationship, it would also try to provide you with the right cardinality to choose with. So, you do not need to worry about it. Now, I'll just go ahead and click on OK. Now this is my merge result, which is called as the merge one. And here the merge query has got, what are the results that I see? I have my order ID column, the ship mode column, and the order details. But in my order details column, I see that these have been stored in the table format. And how do I get all of the other records? There is a expand button next to my order details. So if I click on my expand button, it provides us with all the columns that are coming in from my order details table. All right. And so what is happening basically when we perform a merge query means it is trying to combine two both the tables together in the same table structure. So it is modifying the overall table structure itself, or it is altering the table structure. Okay, it's the and because of which the data volume gets increased and gets expanded. So when we do a merge query, it usually appends or it usually adds up all the rows or all the columns in that particular new structure, and therefore it is expanded. So let me quickly click on this expand and try to select few columns. And maybe I don't need the order ID and ship mode, so I'll bring in other columns. So I'll just select all and then unselect whichever is not needed. So I've just unselected the order ID and rest of all of the columns is required. So I just select all. And now if you notice, after merging the query based on both the tables, I have 10 columns with 10 rows. All right. Now let me go to the original tables, which is my orders table. So if I go back to my orders table, what is the table structure of my orders table? I have two columns and four rows. So you have order ID 1, ship mode second column, and there are four rows in this particular table. Whilst my order details table has how many? So there is like 9 columns and almost 1,000 plus rows, right? Now let me go back to the merge query. Yeah. So this is my merge query, and you could see that all of my records are now been displayed on my single table itself. Now let me try to close this. Okay. So we've got our so I'm going to the data view mode and I'll try to select the merge one table, and you could see that all of the columns that we've seen or that are coming in from both the tables have now been appended or like combined together in the same table structure. All right. So here if you notice, when we perform a merge query in Power BI, it alters the table structure and combines all of the columns that comes in from both the tables, and therefore the volume of the data gets increased and expanded as well. Whilst when I try to create a relationship between both the tables, you could see that there is no new structure or a new table that got created. Rather, this is all created on the logical layer, while the other one is created on the physical layer, which means that internally itself, both the tables got combined together and it has expanded the table structure. While performing the relationships, it does not happen in that way, but rather it creates a logical connection. And only when you try to query the columns from the respective tables, it tries to fetch or understand what kind of a relationship is existing between these two tables and pulls out the records accordingly. So let's say if I go back to the report view and try to bring in orders table, so I'll bring in my ship mode, and from the orders table I'll try to get my sales. So if you notice here, or maybe quantity. Okay. Anyways, I'm just trying to focus on these in values, right? So as you could see here, I have the data coming in from both the tables based on the relationship that I have defined here. So what exactly is happening? There is a filter direction. So on my orders table, there is number one indicated, saying that there is only one record in this particular orders table which is connected or which is having multiple records. So multiple records are indicated or denoted by the asterisk denotation. So here it is trying to filter the data from the dimension table or the lookup table to that of your data table, and that results have been populated on your report level. On the other side, let me go to the other page. Now let's say if I try to bring in the same, which one was that? Okay, merge query result. So ship mode again, and sales. Okay, so here when I try to bring in the ship mode and the sales, it's still the same. However, it's just that the only difference is that it had created a physical layer or a physical structure within the new table, and from there it has tried to retrieve the table results. And on the other side, when you try to pull up the records from the relationship based tables, it is not it is maintaining the original table structure as it is, and only based on the query requirements it's just trying to go and find what kind of a relationship is existing between both the tables, and accordingly it is displaying the data here. All right, so this is what the main difference between both of them. And yeah, I think in terms of performance, I would still, or maybe in generally, everyone would prefer to have a relationships being created, because it's ideally created on the logical layer and it's well suited as well, because we don't want to expand our tables and increase the volume of data within the new structure, right? So therefore, we suggest, or the best practice to have a good data model is that preferably go for a relationships being defined, or creating a data model from the model view, and try to avoid creating merge queries, because that actually creates a new table structure within your physical layer of the tables. So that is all about the differences between the merge query and the relationships in Power BI. Now, the other topic is creating schemas and modeling. So, I believe yesterday we have looked at an example of healthcare system where I've tried to create tables then and there on Power BI desktop, and try to create a schema model also, right? So I'm not trying to go through it again, but I would try to encourage you to please go ahead and create such schemas on your own, so you can think about any such common use case that you are familiar with and try to create your own schema so that you are well versed with the modeling terminologies and you're comfortable in creating modeling on your real time basis. The next topic is managing and editing relationships, and I think we have also covered this already. So if I have to manage my relationships, I can go to this model view, and on the home pane there is an option to select manage relationships. So just select the manage relationships, and here you can just create a new relationship based on what is needed and define it as needed. So new relationship is again common. You just need to select based on which two tables you're trying to relate them together, and once you select the tables and select the common column between both the tables, then the cardinality is automatically identified and also the cross filter direction. Okay, so that's about the editing and managing the relationship. Next topic is active versus inactive relationships. Okay, let me show you that with an example. Um, okay, so I think here I could create it. Maybe not. Let me try to do one thing. I'll go back to the table and let me preview what is there in my orders table and on my order details and the O date. Okay, now let me go back and so I have my O date table that has order date and ship date, and my orders and order details. All right. So you could see that the moment I have pulled in the tables onto my data model layout, uh, Power BI has I automatically given the relationships between those tables. So now let's say that it has by default selected, or it has by default given the relationship based on order date here, right? Now let me check if it has. No, it doesn't have, right? Okay. Ship date, I need that to be included in my order details table. So I will go to this. Ship date is also there. Okay. I think, yeah. So I didn't notice that. So ship date is already there. It's my bad. So let me just try to drag and drop the ship date from the O date table onto the order details data table and see what has happened. So the moment I try to drag and drop the ship date field from my O date to that of the order details, Power BI has identified that these two columns have multiple records existing in both the tables, and therefore it is having a cardinality of many to many cardinality. So unlike to what we have seen earlier, this cardinality is something which we normally do not encourage, and therefore it's likely that we should try to get rid of it. So before that, let me try to provide you with the example which I wanted to show you, and then we will go with another example. So I'm trying to connect to the Superstore data set, which is loading the order date, orders, and okay. I'll try to get my returns table. I'll go to the data transformation layer, which is on my Power Query editor, and I just need to modify or make the first row as my headers on my returns table. So I'm not changing anything, but I just wanted to show you something which would help you understand it better. Okay, now let me try to bring in my orders table and my returns table. And okay, so you notice here. So if you notice here, this particular dotted line is nothing but your inactive relationship. So if I go to the properties of this relationship, you can understand that this particular checkbox is not selected and therefore it is not active at the moment. Why is it not active? Let me select it. So you see that um, yeah, here it is not providing any pop-up message, but usually what happens is that whenever there is any relationship already established between those two columns in a different layout, then Power BI will tell you that there is an already existing active relationship between these two columns, which is conflicting to that of your existing one. So it will try to provide you with such necessary information so that you are good to take the better decision on whether you would like to make it an active or whether you'd like to keep it as an inactive relationship. So in that way you are able to know when and which particular relationship can be made or modified to active and inactive relationship. All right. So that's about the relationships cardinality and the inactive relationship. Now let's try to understand the filter flow or the direction and the bidirectional filters. So filter direction on the other side is nothing but it's a way of indication that how the filtering happens on the report level. So for example, here there is a arrow indicated from the dimension table, that's your lookup table orders going to your orders table because this is termed as your fact table or the data table, and therefore the arrow is going towards the many side of your table because always the data filtering would happen from your dimension table or from your lookup table to that of your fact table. So that is one key point that every one of us should be able to remember. And what happens if you change this particular arrow or the filter direction to both? Because there is an option to select single or both, right? Now, let's say if I select both and save it, you see that the arrow indication has changed from single arrow to double arrow, which says that you can filter the data from your dimension table to that of your fact table or the lookup table to that of your data table and vice versa. So you can also filter the records from your data table to that of your lookup table if there is a need to do that. But you generally we do not filter the data from your fact table because that has a lot of duplicates in it, and therefore the output data that you might look at in your report might not be the appropriate ones. So you'll have to take a close call as and when it is needed. You can make it as a bidirectional, but otherwise we generally suggest to keep it only single direction. Okay, so the thumb rule of knowing or understanding in which filter direction should I have to keep it means always the filter direction goes from your lookup table to that of your data table. And there are two ways of having the cross filter direction. One is a single, the second one is the bidirectional. Single direction indicates that if you're filtering the data from your dimension table to the fact table, then it is called as a single cross filter direction. But if you make that as a bidirectional or both, then it says that you can filter the data from your fact table to that of your dimension table as well. Let me quickly show you with an example here. So let me quickly change this to single and save. And this is your orders to and orders, right? So let me go back to the report view. So I'll go back to the orders too and bring in my category, for example. And here, or maybe profit. Okay. So, okay. So here, let me bring in sales because then I can see all positive values. And yeah. So here you could see that um, I'm trying to format this particular visual. I just wanted to enable the data label so it's easier for me to look at the values as well. And let me quickly collapse the window. All right. So here what I'm looking at is sum of sales by ship mode with a single direction. So what exactly is happening here? So if I go back to the data model view, as you could see here, when I have brought my ship mode and the sales value from my orders table, right, it is trying to filter the data for all the ship mode. So it has only, so there are four different modes of ship mode in my current table, and for all those, what are the total sales value? That is what you could see in this particular table. On the other side, let me try to create it as bi-directional, and then I will show you what happens. Okay. Now let me go back to the report view, and if you notice here, what is happening is it is trying to get the results from both the sides, which is 1288, 1179, 1288 and 1179. Okay, maybe in this particular example, since it has only fewer records in my orders table, we are not seeing the difference much. But usually, when we try to do a bidirectional filtering, you end up with multiple duplicate records shown up on the visual side, and therefore, it is encouraged not to have bidirectional unless there is a need to have it enabled. If not, the recommended or the best practice is that we usually do the filtering from the dimension table to that of your fact table. So that is how you are doing the best practices enabled. Then we have the next topic, which is hiding the fields from the report view. And this is quite important because in real time, we end up having several columns coming up from each of the tables. But usually, for creating any reports, we do not end up using all of them. So it's quite difficult for us to look through all of the fields, and sometimes it is there are so many fields or columns that we'll have to scroll through each one of them to find a certain column name. So that is why the best practice is that if you ever have to create a good data model, it's always recommended that you try to hide all the unwanted fields from your data model and from your report view. So how do you do that? So you can simply select, so let's say that this is your fact table, right? So in your fact table, you don't need to have your foreign keys enabled. So what you can do is like simply select a particular column and then press and hold your control key for multiple selections. And now if you expand the properties pane, there is an option called is hidden. So you can just select is hidden to from no to yes, and which would automatically show you there is a eye icon with a cross mark, and that says that okay, this particular column or this particular field is now hidden. And also on your right side within your data pane, within your tables, you can also see that it is indicated with a hidden icon next to that. So why is this helpful? Now let me show you. If I go back to the table view, okay, which one did I do? Order details, right? So now if I go back to the table view, And if I go back to the order details, now you do not see any of those foreign keys which I've hidden previously, and therefore it is simpler and easier for me to navigate and find the right column that I'm looking for my reporting. So in this way, you are trying to create a clean data model for your reporting layer. All right. So it's always a best practice to hide all unwanted columns from your data model or from the respective tables. So how do you do that? There are multiple ways of hiding this. So the one way is that you can go directly to your data model and select, press and hold your control key from your keyboard, and once you select all the respective columns, go to the properties pane next to that, and if you scroll down there is an option called is hidden, and you just need to enable this toggle to yes. That's it. In one go, all of the selected columns would be hidden from both the sides, from your data model and also from your reporting layer. Else, the other approach is that you can normally go to any of the columns. So let's say I'll go to maybe another table, so I can show you how it is different. So let's say that if I wanted to hide maybe this order ID. So when you hover your, or when you place your cursor onto that respective column name, there is an eye icon again. So you can just simply select and keep it hidden. So in that way as well, you can hide all the unwanted columns from your table view. So in this way, you are able to clean the data model and enable you for better reporting. And with that said, I think we are left with these fewer topics, which I will be covering it in the next module or in the next session, because I think we have taken a lot of examples and we have covered a lot of theoretical topics in today's session. So I would not want to combine multiple topics in one go, but rather let's take a pace and cover all of them. All right, so in the next session, I will be explaining about all these topics and we will be doing some hands on as well. So, now that we've looked at the theoretical part, let's take some practical scenarios and work on the examples as well. So, I hope all of these topics are now fully understood, or at least I'm able to help you with the basics to that. And going forward, we will try to do a lot of practical scenarios and help you with more detailed explanation. So, if there is any feedback or a suggestion, or if you're looking for a specific topic which I might have missed it in this module until now, please do let me know in the comment section so that I can pick it up for my future videos and put that across. And until then, thank you and happy learning, all of you. Bye.